This video is going to be on writing compounds that have polyatomic ions in them. So everything we've done so far has been compounds such as this or this. Okay, they have just a metal with a nonmetal, a single nonmetal. Okay, a metal with a nonmetal. Okay, those are called binary compounds, or just two elements together. Okay, some compounds have multiple elements together. So these are still going to be ionic compounds, so it's still going to be a metal. It's just going to have a different negative anion with it. So the bottom of your periodic table, there's a list of what are called these polyatomic ions. Poly meaning many atoms, okay, ions. So the bottom of your periodic table's got this list on there. You'll never have to memorize these as we used to in the past. And what these are groups of atoms that now have a charge. Okay, for some reason in nature, there are groups of atoms that kind of stay together, but they have a charge. Okay, so they're looking for something else that has a charge to equal them out. So remember, when we make compounds are always neutral. Like this is a positive 2 charge. These two bromines are each a negative 1, so that's a total of negative 2. So compounds always are neutral. So these polyatomic ions are not neutral. Okay, they're still a group of atoms bonded together, but they are not neutral. So they really want something else to make them neutral. In other words, they're looking to gain an electron from something else and wants to give an electron away. So here's an example one. It's called the perchlorate ion, and it's ClO4 negative 1. So what that means is you have a chlorine. I'll never make you draw these, by the way. So you have this group chlorine with 4 oxygens bonded to it with a negative 1 charge. Okay, so it's looking for something positive to combine with. Since this has a negative 1 charge, it might combine with something like sodium that has a positive 1 charge. Okay, so it's now a group of atoms with a charge rather than a single element with a charge. Notice that these polyatomic ions are all negative, okay, except for a couple of them. They're listed way off to the left. The only positive one that we will ever use is the ammonium ion. So that's the only one we'll ever start a compound off. So every other one we have here is negative, so it'll always be at the end of a compound as we're writing compounds. These are organized by charge. These are all negative 1s, negative 1s. These are all negative 2s. You'll kind of start to know the ones that we use primarily as we go through. If you look at the names of them, okay, so remember like when we had a compound like this, we always changed the ending to "ide," sodium bromide, or sodium nitride. Remember those endings were all in "ide." So usually when something ends in "ide," it's a single element, single anion off the periodic table, one of the nonmetals. Most of these end in "ate" or "ite," ATE or ITE. Okay, there are a couple of them that end in "ide," like hydroxide. Okay, but most of them end in "ate" or "ide," so that's how you know when they're there in a compound. So let's write a couple formulas with these. So I've got a list of compounds here. Same thing we've done in the past, we look up the charges. So sodium is a positive 1, just look on the periodic table. Look at your ending here. Ends in 8, it's off that polyatomic ions list at the bottom of your periodic table. So you got to find sulfate, not sulfite, not sulfide, but sulfate. And the sulfate ion is SO4 with a negative 2 charge. You always write this entire thing down. You can never change this number right here. That 4 will always be there. You cannot change that number. This is a group of elements with a charge in there. Okay. Now we do the same thing we've been doing. We need 1 of this group and 2 sodiums. So we need a couple sodiums to get 2 positive charges to equal out the 2 negative charges. Okay, so really we essentially have 1 of this group. So we're going to use some parentheses. We don't need parentheses in this one because there's only 1 of that group, but there is 1 of that group. Okay. So if we ever got to have more than 1 of that group, we have to change the number outside of here. This number does not change. Calcium hydroxide. Again, this is one of the ones that does end in "ide." Okay, people want to say this is just hydrogen, but it's hydrogen and oxygen. So it's on the polyatomic ions list. Calcium's a plus 2 charge. This is a negative 1. Well, if this is plus 2 and this is negative 1, we're going to need a couple of these to equal it out. And we'll need a couple of those. So to show that, we show this as calcium with 2 hydroxides. So that 2 means we now have 2 of those groups, all right, that are connected to this calcium. We'll never draw these compounds, but essentially you have a calcium connected to an oxygen which has a hydrogen connected, connected to an oxygen which has a hydrogen connected. So it's a calcium with 2 AOH groups. We'll never draw these compounds, the structural formula like we did, the binary ones. A couple more here as we're going. Iron, again, the 3 is just the charge on the first element. Nitrate, that's one of the polyatomic ions off the bottom of your table, is a -1. So we go, again, you write the whole thing down. Some people put them in parentheses every time they write them down, so you can if you want to. And then make sure your charges are equal. This has got 3 electrons it's losing. This is gaining 1. So we're going to need 3 of this group and 1 iron. We'll do a couple more here. Zinc is a +2 charge. Carbonate, look on the polyatomic ions list, is CO3. It's a -2. Remember, if your charges are equal, +2 -2, we're good to go. Okay, good to go. This one's a little hard to see because of the glare, but this is aluminum, which is a +3 charge. Nitrite, so pay attention to the ending. There's a difference between nitrate and nitrite. The ion is always 1 less oxygen in there, but you don't have to memorize that. So it's NO2 with a -1 charge. We need 1 aluminum, 3 nitrates. 1 aluminum, 3 nitrates. Let's do maybe one more here. Lead, Roman numeral 4. So remember, that's a +4 charge for lead. Nitride. Okay, now you got to be careful. This was nitrate, which is NO3. This is nitrite, which is NO2. When it is nitride, that means it's just nitrogen in the nonmetal section of the periodic table. So you got to look at it up in the periodic table. It is a -3 charge. So we need 3 leads and 4 nitrogens. We don't need parentheses now because we don't have a group of ions with a charge. Okay, we don't have a group of them that we have. We just need that. So that's writing the formulas. Naming them, not too tough. The Roman numeral gets tough. We'll work on that as we go through. I may show a couple of those, but that will be taught in class a little bit more. But if we're naming these, name the Na, sodium. If there is a group of atoms, now you name that as one group. So you don't name this sodium sulfur oxide. Sodium, and then find SO4 on the polyatomic ions list in the periodic table at the bottom, and that is called sulfate. Sodium sulfate. This one would need a Roman numeral because gold is a transition element. I will show it to you, but I'm not that concerned right now. So gold, you find this on your polyatomic ions list. Okay, so your names will typically only be 2 words. There's a couple that will be 3 words, but gold, you find CrO4. CrO4 is called chromate. Okay, for now, if you can do that. Getting the charge. Getting the charge. Well, there's 1 of this CrO4 group. So I'll write this over here. We have 2 golds, 2 gold atoms, and we have 1 of that CrO4 group. If there was more of them, maybe in parentheses. If I look at my polyatomic ions list, that's a -2 charge. That means these have to be a +2 charge to equal that out. So each one must be a +1. So it's gold Roman numeral 1. Okay. We'll work on on that. Again, same thing down here. Calcium. OH is off your polyatomic ions list, so you call it calcium hydroxide. Okay, going through a couple more of these. You would call this chromium. Just oxygen by itself would be oxide. This would need a Roman numeral. Iron. PO4 is called phosphate, so iron phosphate. Potassium, if it's just off the periodic table, just nitride, IDE on the end. Okay. One more here. NH4 is a polyatomic ion. It's the only one that will start a compound because it's the only positive one that we're going to use. So It's called the ammonium ion. So that's called ammonium. And SO4 is called sulfate. Lead, SO3 is called sulfite. Magnesium, this thing is called acetate, magnesium acetate. That's all we got. Have a good day.